Hey guys, we are going to be working on simplifying radical fractions. So in other words, we're going to look at division and how do we clean that up when we're dealing with our square roots, cube roots, and imaginary numbers. Okay? All right, so kind of just to get you a general idea of what we're talking about here, right? We know that this is simplified because we know we can't break down that square root. Okay? But here, this is not simplified because we can break that 12 down to 4 and 3 and then clean it up. Okay? So same thing here, right? Everything looks good. This is a problem, okay? This guy's okay because he doesn't have a radical in the denominator, but these two are no good, all right? So our job is going to be how do we get that radical out of the denominator? And we talked earlier in this chapter, understanding that one big square root is the same thing as having two little square roots, right? So we have that denominator or sorry, we have that radical in the denominator. How do we get rid of it? Okay. All right. So we're going to do what's called rationalizing the denominator. Okay. And all that is we're going to remove the radical from the denominator. Okay. So when I'm looking here, our radicand can have no fractions. No radicals can appear in the denominator, and our radicand, right? Remember, the radicand is that number on the inside, okay? Can't be broken down anymore. So we're kind of looking for this stuff right here. So when I'm looking at this guy here, I've got a problem because I have the square root of 6 in my denominator. I got to get rid of it, okay? So in this case, we have a couple options because we do understand that two little guys is the same thing as one big guy. All right, so we could go ahead and just reduce our fraction right away, which I recommend doing. All right, and we could look at just the square root of 1/3. Now, we also could just work it straight from this guy. All right, so if we were to work it straight from this guy, we would multiply by the square root of 6. So basically, whatever's in our denominator is what we're going to multiply by. And so we'll multiply the top by the square root of 6. So we know that when we multiply those insides together. So we get root 12. And then in this case, the square root of 36 is really just a 6. And that's going to be true every time, right? The whole point of us is to get rid of the square root in the bottom. That's why we're multiplying by that square root of 6. So 6 times 6, always going to get us a 6 down there. So at this point, I've got the square root of 12 over 6. Now, I can't clean this up. This is inside the square root, and this is outside the square root. They don't intermix, right? Outsides go with outsides, insides with insides. Okay. So with that being said, though, square root of 12 we can reduce. So if we break that guy down to 4 and 3, right? The 4 is going to come out. So I'm going to get 2 root 3 over 6. Now I'm looking at my outsides, and these guys can cancel. And so I'll end up with 1/3. Okay. So your final answer, I don't care if you put that 1 in front or not, right? Will be radical of 3 over 3. Now, let's go back over here real quick, though, because remember I did say, two little guys, same thing as a big guy, we can reduce the 2/6 to 1/3 right away. And so if we chose to do that, we would then multiply by the square root of 3, and that would give us the radical of 3 over the radical of 9, or the radical of 3 over 3, because the square root of 9 is 3. And so in this case, I didn't have outside numbers to reduce because I reduced them early on. It does not matter which way you do it because you're getting the same answer either way. Okay. All right. So I'm looking at B, square root of 10/3. I can't reduce the 10/3. So whatever's in the denominator is what I'm multiplying by. So I'm going to multiply the top and bottom by 3. So I've got radical of 30 over the radical of 9, which we know will just be a 3 on the bottom. Now, radical of 30, we've talked about that in class a little bit, won't break down. So this is going to be our final answer. Okay. So on this one, right, to get rid of the square root, just multiply by the square root of 5 on top and bottom. So on the bottom, I have the square root of 25 or just a 5, okay? On the top, I'm going to have 4 root 5. Remember, this is outside number, inside number. We don't put those together. So we're going to end up with just 4 root 5 or 4 root 5 divided by 5. And in this case, the 4 and 5 on the outside can't reduce, so I can't go any farther, okay? All right, looking at this guy. Okay, couple options. We can multiply by the square root of 8 and then kind of clean it up. Or if you wanted to go ahead and multiply by 4 and 2, right? And bring that 4 to the outside, you can do that. And so you would have 3 root t over, bring that 4 out, 2 times 2 is 4, radical 2. Now, you still have a radical, though, that you've got to get rid of. So at this point, I'm going to multiply by the square root of 2. I'm not going to multiply by the 4 because the 4 is fine. It's not in square root. I'm not worried about it. All I'm worried about is that guy right there. And so when I do that, I'm going to end up with 3 on the outside, radical of 2t. On the bottom, I have 4 times the square root of 4, or really just 4 times 2, which will give us an 8. So in my numerator, I have 3 root 2t, and my denominator, I have 8. And then again, I'm looking to those outsides, 3 and 8. Can't clean that up, so this right here is going to be my final answer. Okay, now let's backtrack for a second. If, when you came back and looked at this guy right here, okay, if you didn't want to break down that 8 right away, no big deal. Oh, that's a t. Sorry. Let's put that t back in there. Okay, you could multiply it by the radical of 8 on top and bottom. You can do that. All right, and so you'll get 3 root 8t. On the bottom, you have a 2 on the outside, and you have the square root of 64. Well, we know the square root of 64 is just 8, so 2 times 8, when I multiply those, will get me a 16. So I have a 16 on the bottom. On the top, I know that this 8 will go to 4 and 2. I know the 4 will move out. And so I'll end up with the square root of 4 is 2. 2 times 3 is 6. And inside, I still have a 2 and a t left. And then in this case, now you're going to have to clean it up a little bit on the outside and reduce those outside numbers. So I'm going to cut them in half, and I'm going to get 3 and 8. And again, notice how that's getting me back to the answer we did earlier. So again, it doesn't matter if you clean up and then rationalize your denominator, clean up again if you need to, right? Or if you just go ahead and start cranking and just clean at the end. Doesn't matter which way you do it. Okay. All right, now let's start taking a look at variables. Okay, I like to kind of clean stuff up right away just because I think it makes the numbers easier to work with. But again, that's up to you. So I'm going to go ahead and call this the square root. I'm going to go 1 and 2 there, right? So I've got 1/2. My b's, I'm going to go ahead and clean those up and get just the b on the bottom, right? Because we subtract different levels, subtract our exponents. And then c to the 6 is still hanging on top. Okay, so now I'm going to multiply by the radical of 2b. So in my numerator, I get 2b c to the 6th. And my denominator, it's 4b squared when I multiply 2 times 2 and b times b. Or, again, we know that that is just going to go directly to 2b. So again, right, I've got 2 of them. They're pairing up and moving out. It's always going to be the same if you haven't figured that out yet. 2 5s turns into a 5, right? 2 radical 6s turned into a 6. Okay, so it's kind of the same thing over and over and over. All right, so I got 2b on the bottom. Okay, on top, the square root of 2 doesn't go anywhere. B doesn't go anywhere. Now, c to the 6th, I can group up and move out. So I'm going to move out 3 c's, and then I still have the 2b on bottom. Again, I'm looking to my outsides. Can I reduce anything? Nope, can't do anything. So this is going to be my answer. Okay, so again, I will reduce and clean up first. Okay, so I'm going to break this down, divide both of those by 3 and get 3/4. Now my x's, when I subtract those, right, I'm going to get 3 on top because we have more on top. Here, 2 and 6, I subtract. I'm going to have 4 y's on the bottom because that's where I had more at. Okay, now when I look at this, sometimes this works out for us, and it's kind of nice when it does. Do we know the square root of 4? Yeah. Can we go ahead and break down y to the 4th? Yeah, so the radical is going to go away all on its own here. So on the bottom, I know the square root of 4 is 2. I know y to the 4th will give me 2 pairs, and there's no radical left in this case. On the top, though, I still have that square root of 3, and then x to the 3rd, right? I'm going to have 1 pair move to the outside and 1 left on the inside. And that right there is going to be my final answer. So sometimes when you reduce, it'll help you not have to rationalize that denominator because it just works itself out. Okay. All right. Now cubics, a little bit trickier, right? So when we looked at squareds, we know that we needed to get 2 of them to kind of pair them up, move them out, so to speak, or we knew to get to a perfect square that we would know. All right. So we are doing the same thing here, right? I have got to find three of the same thing. Okay, so when I think of four, that immediately goes to 2 times 2, right? So what am I missing, right? Because if I do the cube root there, I need 1, 2. Don't I need a third one? Okay, so what's missing? I'm missing a 2. So in other words, what can I multiply by to get this to a perfect cube? Well, you got to know your perfect cubes first off, but when I'm thinking about that here, I'm going to have a perfect cube of 8. Okay, so kind of what's the closest one and what can I get it to? So to get to an 8, I'm going to have to multiply by that 2. And technically it is a cube root, right? So I'm going to multiply. I'm going to move this down real quick just a little bit. Okay, so I'm going to multiply by the cube root of 2 on top and bottom. So, right, so that's going to give me the cube root of 8 on the bottom, which we know is a 2. On the top, outside stays outside, right? So I'm going to have 5 cube root of 2. Nothing I can do to clean up the cube root of 2. So it's just going to stay 5 cube root of 2. And then I'm looking at 5 and 2. Nothing cancels. So that right there is going to be my final answer. Okay. All right. So again, I'm thinking 3, but what can I multiply to get to a cube root? All right. And in our case, our closest cube root with a 3 that kind of involved would be 27, right? So again, keep in mind, I'm going to need 3 of something to get it to go away, right? So I'm going to need a 3 and a 3. That's going to give me 3 of the same, okay? Or in our case, it's going to give us the cube root of 27, right? That's what this is going to produce, a 27 cube root, okay? So I'm going to multiply by the cube root of, and I'm going to multiply by 9 because 3 times 9 will get me to 27, okay? So I'm going to multiply up the top by the same thing. Okay, so on the bottom, I've got the cube root of 27, which we know will go to a 3. Okay, on the top here, I have got the cube root of 63. All right, and so now I'm trying to figure out, all right, 63, thinking of our cubes, right? 1 squared, or cube, sorry, one cubed, 2 cubed would be 8, 3 cubed, 27, right? So I'm thinking, okay, 63 divided by 27, no good. 8 doesn't go into it. And then I'm going to my 4s. Well, the cube root of 4 is 64. That too big, right? So we're just going to have the cube root of 63. We couldn't break that down at all. Okay, now in this case, right, 3, there's a 1 here and a 3 here, nothing reduces. I can't do anything with that, so this is going to be your final answer. Okay, all right, let's take a look at C. Okay, so again, I need to get to a perfect cube. I've got a 6. I'm going to need 2 more 6s, right? So I'm going to need to get to, if I think about it, I'm going to multiply by, so maybe I'll put it on the bottom here, right? I would need a 6, and then I'm going to need 2 more 6s to get to my cube root. When I look at the y's, I've got 2 y's. I'm going to need 1 more y as well, right? Because I need a group of 3, and I've only got 2 here. Okay, so now I have got 216 y to the third, and that's what I'm going to multiply both these parts by. Okay. Oh, not 216. I'm sorry, guys. That's what I want to get to. I'm sorry, erase that step. That was my fault. Let's try that again. So what do I need? I need 6 and 6. I need a 36. Sorry. So cube root of 36, and then I'm going to need a y because I'm missing a y. Now that gets me to the cube root of 216, y to the third, which we know will give us 6y when we work that out. Okay, so now I'm going to multiply the top by 36y. All right, so I have got a 7 on the outside. Cube root of 48 times 36 is going to be 1728. Ooh, I'm going to have my work cut out for me on that one. And then I've got x to the 4 still and y to the 9th now. Okay. All right. So thinking about my perfect square list here, I got some work. So 1728. I'm going to start dividing by my perfect squares. Okay, I found 64 and 27. All right, 64 and 27. However, those are both cube roots, right? So the cube root of 64 is 4, and the cube root of this would have been a 3. So really, like, I'm going to end up having, if I work all that out, it's going to end up going to be 12s, 12 times 12 times 12. That's what we're getting here. Okay. So I'm going to do 4 times 3 is 12. So cube root there. I'm going to multiply it by the 7 on the outside. So 12 times 7 is 84. Okay, now I'm looking at my x's. I have one group of 3 coming out. I'm going to have an x left on the inside. Y to the ninth, I'm going to get 3 groups out of that. Okay. All right. Now, this is a situation where we're going to have to reduce our fraction on the outside, right? I've got 84 sixths, which is going to go to a 14 when I divide. I still have the x there. Now, when I look at my y's, I subtract my y's, and that's going to get me to y squared. Oops, squared. And then I have the cube root of x still hanging out there. And that's going to be my final answer. Whew, that was a tough one. Those are big numbers. Okay. All right, let's try again. All right, so 25. Well, I know that that's going to get me 5 times 5. So what am I missing? I'm missing a 5. Okay, so what else am I missing? I have an X. I'm going to need an X and an X, right? So now I've got 3 5s. I've got 3 X's. So I'm going to multiply by the cube root of 5 because that's what I'm missing. I'm missing a 5 and I'm missing those 2 X's, X squared. Okay, so I'm going to do that on top and bottom. All right, so on top, 2 times 5 is 10. A and X squared. On the bottom, when we do that, right, we get the cube root of 125 x to the third, which we were working it towards 5x, right? Again, the radical has to go away in that denominator. I get 3 radical of 10a x squared on top. Again, outside with outside, no reduction can happen. So that's going to be my final answer. All right, and that concludes the first part of the notes for this lesson.